Hello, hello, I am Mrs. Edwards, and it is time to do math, and I love it. Today we are going to learn the chain rule. But before we jump to the chain rule, let's go ahead and quickly review a couple of ways that we may have found the derivative of this given f of x. We may have used the power rule, or perhaps the product rule. Let's take a look at it with the power rule. If I wanted to use the power rule, the first thing I would need to do is FOIL x squared plus 4 times x squared plus 4. Combining those middle terms, I get x to the fourth plus 8x squared plus 16. And now that I have that look of a number x to a power plus a number x to a power, I can use the power rule. So the exponent moves to the front, subtract 1 off the exponent. So this first term would become 4x to the third. The next one, 16x, and then the derivative of 16 is 0. So here we have our derivative using the power rule. If we wanted to use the product rule, we'd want to write x squared plus 4 next to x squared plus 4, just side by side. And then we're going to be able to take the red times the derivative of the purple plus the purple times the derivative of the red. So if we do that, just setting it up there, then the derivative of x squared plus 4 is 2x. And same thing there with the red, derivative of x squared plus 4 is 2x. I could distribute 2x through x squared plus 4. Do that again there on the end, combine like terms, and what do you know? We have the same answer. Okay, so we have two ways of doing this problem so far, and we're going to add a third. Before we add that, you're like, why do I need another way? Well, how about this one? Let's take the derivative of x squared plus 4 to the 18th power. You want to use the power rule or the product rule? I don't want to multiply this out so that I can get that look. So no, thank you. This is why we want the rule, chain rule. So chain rule, I want to first explain kind of the notation here a little bit. Chain rule really comes from composition functions. And so we want to identify when we have a composition of functions. Here we have f composition g of x. If we were to take the derivative of f comp g of x, we would get f comp g prime of x would end up being f prime of g of x times g prime of x. You're probably thinking, what the heck? So let me break that down a little bit further by first reminding you what is a composition function. All right, let's say that I wanted to find, no calculus here, just a review of pre-calculus. If you wanted f comp g, then you would start with the f function, so x to the third, and every place we see an x, we would replace it with 2 minus x, the g function. And there we have f composition g of x. Well, that piece right there, that input function, that is the g of x up here in our chain rule. So input function, let's just look at a couple more. If I were given f and g, and I wanted f comp g of x, I would start with the f function, the sign of x, but replace the x with 2x. So that ends up being the sign of 2x. 2x is that input function. Now notice if I simplified, it is really common for those parentheses to be left out, but they are there. Okay, one more. F comp g of x. I would want to start with the f function, so square root of x, but every place we see an x, we would replace it with 2x plus 9. Similarly, that input function 2x plus 9, we wouldn't see the parentheses necessarily. So we want to be able to identify what was that input function to be able to use the chain rule. Now the input function is something more than x, and if we used really good notation when we made that substitution, there would be a set of parentheses around the input function. But as you can see one more time, here in that first example, 2 minus x was in parentheses, but when I simplified in that second example, the 2x was no longer in parentheses, or in the third example, 2x plus 9 is no longer inside parentheses. But the input function is what is in parentheses or what is in grouping symbols. And I'm going to simply refer to that as ugly, right? We have this mess of stuff inside of parentheses instead of just x. Okay, so let's say I want to find f prime of x. Then we would be taking the derivative of ugly and then chaining on the derivative of ugly. Oh, don't call me ugly. It reminds me of that song. You ain't got no alibi, you ugly. Ooh, ooh, you ugly. All right, so you can go to that YouTube link just to hear that song if you'd like. So let's go ahead and identify the ugly. For using the chain rule, we need to really call it out and say, you're ugly. So what is ugly here is that x squared plus 4. So what I mean by take the derivative of ugly and chain on the derivative of ugly. If this would have just been x to the 18th, then we would have 18x to the 17th. We're just taking the derivative of ugly. But we have to chain on the derivative of ugly. All right, so when these uglies were x squared plus 4, then each of those are x squared plus 4. But I want you to look at that one more time. Try to color code that to help you really see it. So the 18 moved to the front, ugly to the 17th. But at the very end, anytime you have called out ugly, you're going to have to, at the end, multiply by the derivative of ugly. So that is x squared plus 4. So each of those uglies, I'm just making those x squared plus 4, and we have the derivative. Notice the x squared plus 4 did not change when we were taking the derivative, and that 18 moved to the front, subtracted 1 off the exponent. That part was not touched. But at the very end, we're chaining on, chaining mean multiplying by, the derivative of that input function, derivative of ugly. All right, so the first part doesn't really change, so I'm just going to drop that down. And then the derivative of x squared is 2x, and the derivative of 4 is 0. So the derivative of ugly there is 2x. Little simplifying, 18 times 2 times x squared plus 4 to the 17th. There's my simplified answer. All right, let's go ahead and go back to the one that we already used, the power rule and the product rule. We could use the chain rule as long as we call out the ugly. That would be that x squared plus 4. So we're going to take the derivative of ugly times ugly prime. In other words, we're going to move the 2 to the front, subtract off 1 from the exponent. So we just used the normal power rule. But because we have more than just plain x inside of parentheses, we have an input function, we have to chain on the derivative of ugly. So just going back to the variables, right, that was x squared plus 4. So each of these are also x squared plus 4. All right, so 2 to the front, subtract 1 off the exponent. That x squared plus 4 inside of there, it didn't change at all. Chaining on the derivative of what's inside grouping symbols. All right, now the derivative of x squared plus 4 is just 2x plus 0. So all that becomes 2x and everything else stays the same. Okay. And then a little simplifying could take place. Multiplication is commutative, so we have 2 times 2x times x squared plus 4. So we have 4x times x squared plus 4. Distribute that 4x through, and we have the same answer we got when we used the power rule and when we used the product rule. Here's another one. Okay, normally if you just had the square root of x, you could rewrite that as x to the 1/2. Well, here I am going to still write what's inside of grouping symbols to the 1/2, right? All of that in the radicand is in parentheses to the 1/2. If this was just x to the 1/2, we would go 1/2 to the front, subtract 1 from the exponent, and we'd have 1/2 x to the -1/2. But instead of plain x, we have a bunch of stuff inside of parentheses. So I am calling that out as ugly. All right, so then now we're going to apply the power rule to ugly. We're taking the derivative of ugly, but chaining on the derivative of ugly. So 1/2 to the front, ugly, to the -1/2, because I subtracted 1 from the exponent. Chaining on, multiplying by the derivative of ugly. Anytime you see more than plain x inside of grouping symbols, at the very end, you will multiply by the derivative of that. Okay, so that ugly piece was 4x cubed minus 5. So we have a little bit of calculus there on the end. The derivative of 4x to the third is 12x to the second, and the derivative of minus 5 is 0. So that front part basically staying the same. All I did was, because the exponent here was to the power of -1/2, it kind of got down a little low, sorry about that. So I moved it to the denominator just to simplify, and then the derivative of 4x cubed minus 5 is 12x squared. Simplifying just a bit, this 12x squared is over 1, so numerators times numerators, denominators times denominators. And we have this. I did the 12 and that 2 right there. I made it 6 over 1, so that's why we don't have 2 in the denominator anymore. Okay, so there is the derivative of y. Let's try another one. If you were just finding the derivative of sine of x, the answer would be cosine of x. But we don't have just sine of x, we have sine of ugly, something more than plain x. So I'm going to call that ugly out, and I'm going to have the derivative. So derivative of sine of ugly is cosine ugly, but chain on the derivative of ugly. Okay, so I'm just changing those back to x squareds. All right, then the derivative of x squared is 2x, and then simplify, multiply that together. Please, oh please, no algebra atrocities. Do not call that cosine of 2x cubed. That is not equivalent. The cosine trig functions of something is like a brick. There's no distributing through. There's no separate. But we're going to put the 2x in the front. So 2x cosine x squared, not cosine of 2x cubed. That's not the same. Here, we're going to use multiple rules. First thing we need to notice is that 4x squared sine of x cubed is really 4x squared times sine of x cubed. All right, so we're going to use that product rule, because when we have two things multiplied together, and they both have x's in them, we're going to have this first one times the derivative of the second plus the second times the derivative of the first. So let's put those ones in. Okay, next let's go ahead and bring down what is already basically done. So 4x squared is still 4x squared. I'm going to put this one right here off for a second, and then I'm going to bring down this sine of x cubed, and then the derivative of 4x squared is just 8x, so bring down times 8x. Now let's go ahead and focus on the derivative of sine of x cubed. Okay, when I want just clear everything else out of your mind, our only focus right now is the derivative of sine x cubed. If we were finding the derivative of just sine x, well then the derivative would be cosine of x. But because it's not plain x, it's more than just x, we have ugly. All right, so let's call out that ugly. X cubed, you're ugly. So the derivative of sine ugly is cosine ugly times the derivative of ugly. Cosine x cubed, chain on, times the derivative of x cubed. Now the derivative of x cubed is just 3x squared. Let's bring down everything. We just need to simplify this, all of this right in front of the plus sign. So 4x squared multiplied by the cosine of x cubed multiplied by 3x squared. So 3 times 4 is 12, x squared times x squared is x to the fourth, and then we still have times cosine x cubed, plus, and then right here multiplying sine of x cubed times 8x, that is 8x sine of x cubed. Our derivative has been found. Please, no algebra atrocities. Do not call, for example, this last term sine of 8x to the fourth. Those are not equivalent. You cannot do that. These are the problems that you are going to have as homework problems. And so I just want to make sure you're off to a good start. Let's call out the ugly together. So this first one, 2x would be your ugly. So sine of ugly is cosine of ugly, chain on the derivative of ugly. So it's going to be cosine of 2x times the derivative of 2x. Okay, this next one, the x minus 1 is our ugly. So if it was just the derivative of cosine x, it would be negative sine x. But because it's cosine of ugly, we're going to have negative sine of ugly chain on the derivative of that x minus 1. Before I call out the ugly on this third one, I want to rewrite it. So we have cosine of ugly. So if we had the derivative of just cosine x, that would be negative sine x. But because we have cosine of ugly, it's going to be negative sine of ugly times ugly prime. Same thing on this last one. I want to rewrite it. Anytime you have the little 2 in there, that notation, it can make the calculus tricky. This means cosine of x multiplied by cosine of x. But it's commonly written as cosine squared of x, but it's not cosine, just the word cosine being squared. So I'm rewriting it. As soon as you see a little exponent on trig functions like that, your very first step, always rewrite it to that power. Okay, so now all of cosine of x is our ugly. We have ugly to the second power. So you're going to be able to do 2 ugly to the first power times ugly prime. Okay, that next one up there in the corner, the square root of cosine x. Before I call out the ugly, let's go ahead and rewrite it as to the 1/2 power. And if we just had plain x to the 1/2, we could do 1/2 x to the negative 1/2. But because we have more than plain x, it's going to be ugly to the 1/2, so 1/2 ugly to the negative 1/2, chain on the derivative of cosine x. Okay, now this next one here on the right, to the third power. Okay, think about it just like we did this bottom one on the left side. To the third power, rewrite the whole thing to the third power. So all of that is ugly to the third. We might think of this as big ugly because we've got a lot going on. But all of that is to the third power. So 3, all of that to the second power, and then we're going to have to chain on the derivative of sine of 4x. But when you do go to chain on the derivative of sine of 4x, that 4x right there is going to be another little ugly. So you're going to have to use the chain rule twice there. Last one, all of that to the second power. So what you can do there, right, is the whole fraction, all of that fraction is the input function. So the 2 is going to move to the front, 2 to the front, ugly to the first power, and then chain on the derivative of ugly. So we're going to have 2 and then 3x minus 1 over x squared plus 3 to the first power. Chain on the derivative of what's in yellow there. Now, when you do go to chain on the derivative of what's in yellow, you're going to have to use, to take the derivative of that, low d high minus high d low over low squared. You just have these 7 problems to do first, and then we will have a follow-up assignment the following day where you can use the chain rule to find the derivative of several more. But let's just start with a handful. Make sure you have that down where you can identify that input function that I'm calling ugly, and then chaining on at the end the derivative of ugly. All right, go team. You ain't got no alibi, you ugly. Ooh, ooh, you ugly.